Weaving is defined as the interlacing of yarns to form fabric. In order for a fabric to be considered a woven, it must have three properties: yarns in a warp direction, yarns in a filling or weft direction, and an interlacing of these. The shaded area represents a 1-inch wide section of the fabric. The number of threads per inch for the warp yarns is referred to as the sley, ends per inch, or warp count. In this illustration, there are 12 threads per inch. The shaded area represents a 1-inch section of the fabric where the number of filling yarns can be counted. The number of threads per inch for the filling yarns is referred to as picks, pick count, or filling count. In this illustration, there are 12 picks per inch. The relationship of warp and filling thread counts in this graphic is referred to as 12 by 12. The edge of the fabric is called the selvage. It's designed to give stability to the edges of the fabric so that the fabric will not fray during subsequent processing in the textile plant. How do we get the yarns interlaced to form a fabric? The warp yarns must be arranged in a parallel manner and precisely controlled so that the weft yarns can be inserted to form a fabric. The illustration shows the major components of the weaving machine. At the back of the loom, we can see a loom beam that contains all the warp yarns needed to manufacture the desired fabric. After the yarns leave the loom, they go over a whip roll that is part of the warp yarn tensioning system. Each individual yarn then goes through a drop wire that is part of the loom's stop motion system that helps prevent mechanical defects from occurring during weaving. Next, each yarn goes through a heddle eye that is mounted in a harness. The harnesses are used to raise and lower the yarns to achieve the desired design. After leaving the harness, the warp yarns are evenly spread and spaced by a reed. After a filling yarn is inserted at a right angle to the warp, the reed is used to force the filling yarn into the fabric. Then fabric passes through take-up rolls and is then wound into a roll. This selection will guide you through the basics of weaving. A loom beam contains thousands of individual yarns placed side by side onto a flanged beam. In order to have the necessary number of yarns on the loom beam, one must start with yarn packages in a creel. It is not possible to put all the yarns needed for weaving into a single warper creel. For example, if the warp beam needs 3,200 ends and the creel holds only 400 ends, then a section beam will be made on the warper. Therefore, 8 section beams would have to be made to accumulate the needed 3,200 ends. Yarn packages are first placed in a creel, from which they are wound onto a section beam or die beam. The path the yarn follows on the creel is through tension devices and stop motions. Next, the yarn passes through a reed or comb that guarantees even spacing and a yarn sheet width that matches the width of the section beam. In some cases, the section beam is perforated for yarn beam dyeing. For some special types of yarn-dyed warps, such as indigo for denim, a system called rope or ball warp dyeing is used. If rope dyeing of yarn is to be performed, then ball warps must be manufactured. Ball warps are made using a creel that is set up as with other forms of warping. However, the headstock is set up differently in order to condense the sheet of yarn into a rope. The sheet of yarn is passed through a trumpet-like device to collapse the yarn before it is wound onto the ball. The yarn is then wound onto the log like a huge package of yarn. By traversing the rope back and forth across the face of the ball, the package is built evenly with constant tension. The ball warps can be from 500 to 25,000 yards in length. They are added together behind the rope dyeing range in a magazine creel to form a die set. The die set is always a multiple of the number of beams in the slasher set. For example, if there are 12 beams in the slasher set, there will be 12, 24, or 36 balls in a die set. The yarn is then unwound from the balls and is passed through the dye range. After the yarn has been dyed and dried, it is coiled into a large tub or movable storage device. This tub of yarn is then taken to the rebeaming area where each end is separated and rewarped onto a section beam. Whether the yarn is placed on a section beam, a perforated beam, or processed in the ball warp process, the next step in processing is slashing. The section or die beams are placed into a slasher creel or slasher magazine, where the ends from each beam are added together so they can be sized and wound onto a single loom beam. Once assembled on a loom beam, some yarns such as plied and filament can weave without additional processing. But most yarns require a sizing with chemistry to improve the weaving performance of the yarn. This process is called slashing. The slasher is composed of a section beam creel, sizing boxes, drying section, yarn separators or bust rods, and headstock. A pre-wetting box can be located between the creel and the sizing boxes. The sizing boxes apply the chemistry that encapsulates the yarn. Benefits include gluing down hairs, yarn strengthening, and lubrication, which protects the yarn and loom parts. During this process, it is extremely important that each end be kept separate and parallel to adjacent yarns. After sizing, the warp ends must be placed through the proper devices for weaving in the correct order for the desired design and color pattern. This process is called drawing in, where each warp end on the loom beam is pulled or drawn through a drop wire, a heddle that is in a harness, and then finally through a dent in a reed. This is one of the most important steps in weaving, since an incorrect color or weaving pattern will result in second-quality cloth. When changing warps on a loom with an identical drawing-in draft and warp end count, a knotter may be used. The knotter will tie the new warp ends onto the warp ends already present in the loom. The knots can then be advanced through the drop wires, heddles, and reed. This manual procedure to replace a depleted warp with a new identical warp can take less than 1 hour. The changing of the draw to a new one is considerably slower.